So, my name is Chris Guirl. I am David's brother. I am going to talk tonight about DevSecOps and the CI/CD pipeline. I didn't really know what everyone's background was, and how much you know about Agile, DevOps, CI/CD, blah, blah, blah. So I just figured I'd go into all of it and give a high-level overview. If I get too theoretical on you or some mess, because this stuff gets a little bit wishy-washy sometimes, then holler at me. Anyway, I will also be accompanied tonight by our esteemed friends, the Party Parrots, who will be partying throughout the slides. Thanks in advance, Party Parrots.
Party all night long.
Okay. So, in the traditional SDLC, the software development lifecycle, security is kind of like, let's just stick it at the end, right? So in a waterfall style software development, security testing is usually done at the end before release. One might defend this practice by asking, why test it earlier? Most security problems will get fixed by devs anyway by the time we ship next year. And here we have our friendly, dev manager, DBA guy who's, like, whatever, Q1 2027 is fine, and we can do our security testing maybe 2026. So we've all been there. It's not fun. You've probably all seen this diagram or one like it before. Waterfall does everything in kind of a stair step. So you start with your requirements, like, okay, what's everything we think we're going to need to do? What do the customers want? Then you do a big old chunk of system design. And then once everything is designed, you move on to implementation. Each of these steps can take weeks, months, etc. You start into implementation and things get going and devs do their thing. And it just keeps on going forever, seemingly. Finally, things are feature complete and you start getting to system testing. And this is where you might do some actual security. If you're not in a rush, of course, every software project is like over budget and past deadlines. So who has time, right? So maybe. And then you get to system deployment and you get it out to production or to your customers, and you finally enter the maintenance phase. And I don't know why it looks so much like the Salesforce logo. I hope I don't get sued. But anyway, don't go chasing waterfalls. That's the point. And that's, I don't know, kind of a straw man. Everybody knows this. So waiting until it's time to ship is too late. As you've probably all seen before, like, there's always limited time. We need to hurry up and get that new release to customers. And for other reasons, I thought I removed that. So security testing is rushed, and we run the risk of shipping like an exploitable flaw and getting, hacked. It's not fun. Anyway, it's easier to fix these things when you catch them early. And here's a sad tale of our old school development manager who's plodding along, doing, the usual process they've been doing for years. Learned back at IBM in the 70s. And they released something with a flaw, and here comes a spy parrot who's, spying on them. Soon you have the pirate parrots join in their festive Halloween costumes, and the dev manager parrot turns into a sad parrot.
That's not a Halloween costume. That's his year-round garb.
Look, they're festive parrots, okay? I'm trying to be thematic here. Right? But anyway, with rickety parrot-based allegory. So we can do better than this, obviously. Lots of things that are better than this. So I'm going to talk about one thing that's like way better, and that's Agile and DevOps. And the idea here is to shift left. So instead of waiting until software is all done to find out that it's got some security problems, let's start checking it earlier. That's a lot of work for a human. So if somebody was have to manually go and security test, for instance, every single software change that ever got made, it would take tons of time. So let's enlist the help of some of our robot friends. so that all of our testing can happen more often and thus move it earlier in the process or shift it left. So if you think about that waterfall, we're going to push the to the left of the timeline there, and do the security testing, the unit testing, the integration testing, and even things like penetration tests earlier and as often as possible. Thus, we get our developers the fastest feedback possible and fix problems before they pile up. And here we have Moonwalking Parrot, who is shifting left, as you can see. And of course, our robot pals join as well. So, what DevOps? DevOps is a set of practices that combine software development, that's the dev part, and IT operations, that's the ops part. It aims to shorten the system's development lifecycle and provide continuous delivery with high software quality. DevOps is complementary with agile software development, and several DevOps aspects came from agile methodology. This is from Wikipedia. That's why that says that there. And I copy and pasted it. I'm not ashamed to say that. DevOps is not one tool or method. Okay, like you mentioned earlier. Sorry, I've forgotten your name, but maybe Josh. Anyway, there's no silver bullet, and there's there's a lot of different things you can do, and it's a synthesis of those things, and it's a combination of methods and the mindset that touches every part of the SDLC. It goes further than just putting code in your IT ops and IT ops in your app code. And this here, this quotes me because I came up with that. That's my original content. Copyright 2020. Me.
Nice.
I also wrote this
Still
helpful.
see you in court.
Yeah, I'm sorry. You'll have to talk to my attorney about that. But I also wrote this helpful, algorithm that DevOps is equal to the square root of the SDLC, which is equal to curly brace dev app plus ops IT and curly brace times agile to the power of team, and that is roughly equivalent to lol hacks WTF BBQ. If you don't understand all that, yeah, it's very technical. If you don't understand all that, you probably need to be, have a little, couple more decades in the IT field, and you'll get it.
Or, just 2 or 3 more shots of whiskey, you'll be there. I promise.
Yeah. Cheers to that. So to kind of give you a visual representation of what the DevOps lifecycle looks like, this is in opposition to our waterfall diagram we saw earlier. So we start out here in the plan phase, as our waterfall diagram started out with requirements and analysis. So you got to figure out what you're trying to do. One of the most important pieces of the planning phase is breaking things down into small chunks, because you're going to repeat this process for every little chunk, and you want it to be a fast feedback loop. So the smaller the change, the easier it is to get through. Once you plan, you're done with the planning, and let's say that your user stories are written, your requirements and all that. Then you go to build. That's the code this stuff portion of the program. And then once developers are done with that, they push up their code and they go into the continuous integration phase. I will go more into that later, but that's a very important part. Sort of the whole background. Once you've passed your continuous integration, you deploy your code into production or whatever other environments. You run your code, obviously, you operate. And then from that operation, you result in some kind of feedback, right? So you're monitoring your performance reports, load testing, whatever you have, right? And that could also, be like support tickets that come in from customer support. That all that feedback goes back into the planning stage, and our parrot is pretty happy. The parrot gets a little sassy as they're going back and forth, and
That parrot is pure sass.
Yeah, that is the sassiest parrot, and then we start to celebrate with Ron Paul and a laser light show, do little flips and all that stuff because we've figured out a way to support iterative software change. We can repeat this loop over and over and over. And we can get a lot of really good results. So it's all about delivering value iteratively. You deliver small bits of value over time, and then you get faster and faster at delivering that little pieces of value, and that all amounts to a big deal. So it's kind of all about the long con. It's all about the long-term thinking, and the more you do each little thing better, the more you optimize this process, the better you can deliver value, the faster you can go, and all that.
Don't think we missed the long con you put in there.
So,
What? No, I don't know anything about scams. What scams? So far so good. Everybody following me? Am I boring you guys to tears with all this?
Your microphone just decided to eat a fan.
so the continuous integration, does that include like the whole testing, or are you just testing in production at this point?
You got it. So continuous integration is where you run all of your tests and all of your making sure everything checks out. So you get everything like done in your non-production environments to make sure it works together. That's the integration part. And that's like new code with old code integrated together, ba-bam. And
Gotcha.
you guys are hearing me, right?
Yeah.
I just saw the mic is dead.
Yeah, it sounds like it's
Yeah.
better now.
Yeah, you're better. I'll warn you if you dive back into a working fan.
Word. Okay, yeah, my computer has gotten noisy due to the GIFs, I assume. Okay, so
I have
let's
a
get.
mute
Yeah,
button that doesn't actually work, so I feel your pain.
Yeah, this is how these things go. Any other like questions so far on like general big picture DevOps lifecycle stuff? Again, I think this is all kind of theoretical, and hope it's not too dry. Okay, so if you could put the internet into a tube, you'd end up with a very long tube, probably extending twice the size of the internet, because when you collapse the internet, it expands, and it would be you wouldn't want to put it into a tube. So this is some theoretical stuff. It's really about the universe, but I think it works for the internet too. And it's from a really important science show called Tim and Eric. Awesome show, great job. I'm sure you've all seen it.
I
Just wanted
haven't, but I'm gonna go hunt that down. That sounds fun.
Okay, so continuous integration, continuous deployment, or the CI/CD pipeline. What the hell is it? So CI/CD stands for continuous integration, continuous deployment. Why does slash mean and? Why do we do that? Like grammatically.
It's and or.
Continuous integration and or. Is it exclusive or is it
Either and, neither or.
neither nor? Okay, never mind. What if it was not exclusive? Okay, never mind. It bridges the gaps between between development and operation activities and teams by enforcing automation in building, testing, and deployment of applications. So this is the key: is enforcing automation. You've got your developers coding away. You've got your IT ops folks running the show, making sure that things stay alive. But what you do, the key there is you put the automation in place. You enforce that that automation to be there in every step of building, testing, and deploying. So your build is your app build is automated. Your unit tests are automated. Your integration tests are automated. Your end-to-end tests, whatever functional tests, whatever you want to call them. And then deployment should also be fully automated. These are all part of the continuous integration, continuous deployment pipeline. Modern day DevOps practices involve continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of software applications throughout the development lifecycle. The CI/CD practice or CI/CD pipeline forms the backbone of modern DevOps operations. So it's like a pipeline, right? And you have your CI/CD pipeline running over here, and you can put it out over here to the internet, right? And this is like similar to what we've seen in like video games or whatever. So your code comes through the CI/CD pipeline, and when you've got everything that's come out, you've gotten all your tests have passed, etc., then you ship it out to the internet. So again, dry slide, CI/CD, boring stuff. Any questions? Are we good?
The
Moving along?
parrot is very helpful.
Ah, yes. I can spend more time with the parrot. This is a science parrot because CI/CD is scientific.
Yes.
He has a flask. I don't know. There's probably drugs in there or something. 'Cause he's got,
The fact that
got
his
some-
face keeps changing color means there must be drugs in there.
there is no
So-
other explanation. I heard a so. Anybody got a
Continue.
Okay.
Continue, because I'm probably about to ask a question you're about to answer. So
Maybe so. Okay. So as you know, the internet is a series of tubes. The internet is not something that you just
God, I
dump
missed that
something on.
screensaver.
It's not a big truck. It's a series of tubes. And if you don't understand, those tubes can be filled. And if they are filled, when you put your message in, it gets in line and it's going to be delayed by anyone that puts into that tube enormous amounts of material. Enormous amounts of material. And I just wanted to throw this in. This is a Confucian proverb that is, foundational philosophy to the internet. If again, if you don't understand this, it's probably because you don't have enough decades of experience in the IT field. Everybody
Pictured
getting
on
that?
my screen, decades of
Yes.
experience in the IT field.
If you're familiar with this screensaver, click now.
It's funny. This GIF was titled "Windows XP Pipes Screensaver 2020." I don't see how it's any different.
It's in 3D.
Yeah.
There's
Okay.
a
We have more
2020
pictures.
version of XP.
Yes. I think they call it Windows Vista.
Riddled with bugs.
Yeah. Yeah. It's great. What are you talking about? Okay, so back to continuous integration, which is, as I mentioned before, really important. Continuous integration means that when devs make code changes, those changes are constantly combined with other code changes and they are tested together. In order to get fast feedback on code changes, all the tests should be automated. This is not insignificant work, but it can be combined with manual QA as a test suite is built to get the best of both worlds and ship code fast. CI is an important differentiator between waterfall and agile software lifecycles. So these are not all just Wikipedia links. I will provide the slides later, and you guys can learn more about that stuff. That's Wikipedia. I think this is a Martin Fowler article. So martinfowler.com has a lot of good information on agile in general and a lot of different practices and this sort of theoretical mumbo jumbo. Okay, so pretty pictures are better than just talking about the mumbo jumbo. So somebody makes some code, right? They make a change to your application. They push up their code and they merge in any code that's recently been created and accepted that other devs have done. It's built and created. The application is compiled or readied for production, whatever you do. The tests are all run. Some reports are generated, and those could be security tests that come out with security reports. Those could be your unit tests. It could be your integration tests. That's your automated QA, etc. And when you get the reports, you say, oh, we found a problem. One of the tests failed. So we go back to the coding stage and we continue on this loop until all of the reports are green. The tests all pass. And then we do a final merge into the mainline and release it to production. And there you go. That's basically the whole CI feedback loop. So again, the idea is that the merging is automated, the building is automated, the tests are automated, the reporting is automated. The only things that are manual should be the actual coding and the release to production, somebody pushing a button saying, yep, it's good to go.
I have one question.
Yeah.
Because this comes up in waterfall, especially very often, is you involve the customer and the client, and along the way, and they approve changes, and then you release it to the people that use it, and all of a sudden, it's not a feature that anybody really wanted or didn't really work. Where in this life cycle is there feedback from the customer and maybe a way to pull something back that's been released?
Good question. So the waterfall, the reason that that's so dangerous is that waterfall is like you do all this work and planning to cascade down upon your customers the joys from above of the new software, right? And it takes so long to do all that and follow all that careful preparation, planning, building, and then rebuilding as it's like the actual integration and testing phase of the project finally begins. That by that time the market has changed and nobody cares about that feature anymore, right? That's like a stereotypical like failure case of waterfall. So the solution really is that if you have these fast feedback loops where you're getting little tiny bits of your code out all the time, and you're getting feedback from customers like, oh, we made that change Wednesday and the customer said the feature didn't work right, and so we shifted the requirements, and so what we worked on Thursday was different, because you can just always be shipping that stuff. You don't have to wait weeks and months, to get it out.
So correct me if I'm wrong, but with the CI feedback loop, the idea is that you decrease the amount of time from coding to release. So you don't, it's not, you're not looking at a month probably from coded to release. You're doing it in quick, fast, you're making very small changes, incrementing those changes and releasing them.
Exactly.
Okay.
So yeah, and it's going from, go ahead, Tim.
I was saying this is like the MVP. Is it, you're talking about like MVP, right? Most viable product.
Yeah, minimum
Yeah,
viable.
you'll release minimum, and then you'll build on top of that after the fact.
Exactly. So yeah, that gets into like product management really, but product management should be specifying the minimum like
Microphone.
Oh gosh, what has happened?
There it goes.
Check it.
Start again.
Weird. Okay, so that's where product managers and good product management comes in, because if you have people that are doing products right, they are going to constrain the problem to the minimum feature set, and we call that the MVP, or minimum viable product. And they say, well, we don't need to necessarily have a full widgeting system built into our web app. What our customer really wants is just to be able to change the link on the home page. And so the minimum viable product, instead of creating a whole widgeting system that allows widgets that are editable or something crazy like that, is just to make a feature that allows them to change the link on the home page. More hard coded, probably, maybe less scalable, but it's faster, it's minimal, it gets the job done, it meets the needs of the customer, and you move on to more important projects, right?
So you've got to have somebody though that is listening to the customer's feedback and then breaking that down into small enough portions to be able to slice it into this process.
And that was good. Something I was going to ask is, should there be and maybe this is just a question about this particular diagram, but it's almost like there's a loop below the diagram we're looking at. This is the diagram that happens in code. There's a loop below that happens in customer feedback, where they take the release and they're consuming it and acquiring feedback that says we need X and pass that up to have that coded. So if you release a new feature that is missing some whiz bang thing, that gets caught and pitched back to the coding side to say code whiz bang thing, rinse repeat.
Exactly. Yeah, and one thing I want to mention here is that release, when you send something out to production, when you release something, you could release it to a beta environment that goes to like your product team, that goes then into like actually user testing things. Maybe you have user experience testing that's done at that point. And you don't actually hold that change back, and you don't actually ship it to production. Or even better, you use what we call feature flags, and there is a in the coding step, you add in like a if customer dot has feature, new whizbang thing, then turn on this feature, right? And then you release the change, but no change actually occurs to your customers except for the ones that you go in and actually specify. This customer gets this new feature, and so they can be your beta testers, your like alpha users or whatever, your super users of your
We call
application.
them guinea pigs.
There you go. That
or
you
the guinea parrots.
Guinea parrots. Oh, that's a good. I think we're gonna need a party parrot on a wheel now, like a hamster wheel. I'm getting ideas. So
Party parrot
at,
on a nest even.
and this is where it yeah, and sure thing. Happy to explain the rules of what I wish our product managers did. No, actually, they're pretty good. And the key is that at this point, because product is over here doing a lot of the specification mostly, but they should also be like doing a little bit of the testing, like when things are ready in like maybe this stage, like, oh, we have a code change prepped, we can send it out to our staging environment, and the product folks can go test it out, and they can say, oh, this is looking pretty good. They would then work with the QA team, who's also giving feedback, right? And then you could also add in I had a thought and I think I lost it. But anyway, the point is, product and development and QA are partners at this point. They're all in it together at every stage of the way. Those three functions mainly, but all the sub functions, where be it like product UI designers and front end developers and back end developers and automated QA engineers versus manual QA analysts, etc. All of them are doing this like cohesive job where they help each other along the way. Like developers should be pairing with QA and say, hey, I'm working on this, can you help me test it? QA and product should be working on this, like, hey, product, we found this difference in your original specification, but is it actually okay? Seems okay, and then product should be working with development again to like, hey, development said the requirements you came up with were too difficult to implement, as written, but here's something that's really similar that's a lot easier and faster. Is that cool? So it's all about collaboration, and when you have this fast feedback loop, it enables your functional teams, your different folks in different departments, if you will, to work together more closely and get in on that action.
So do you get into time frame and kind of talking about from coding to release in a minute? And if so, don't worry about it right now.
Timeframes can vary. It depends on the product and the way that it works. Some products, have fixed releases and stuff like that. But theoretically, it's as short as it takes you to write the code, which could be 5 minutes, whatever, one line change. Get through the automated CI pipeline. So let's say your build stage takes 5 minutes, your tests run in 10 minutes. That's not bad for a couple thousand tests or something. Your reports are feedback from that. And then it's all green. You can merge it and ship it in less than an hour, and the smaller the application, typically the faster this can go. So that's a pretty big argument for, a service-oriented architecture or microservices, where each individual piece does an itsy-bitsy thing, because then the changes get even smaller and you have fewer tests to run, etc. Another good question, though. Where did my parrot go? Parrot's going to sleep on the job. Okay, I'm going to go on. You guys feel free to come back to CI. So just a second to talk about continuous delivery. Okay, so CD, there's 2 CDs actually, and so I wanted to address both of them, talk about the differences. So continuous delivery is a software development discipline where you build the software in such a way that the software can be released to production at any time. So you're doing continuous delivery when your software is deployable throughout its lifecycle. Your team prioritizes keeping it deployable over new features. Get back to that in a second. Anybody can get fast, automated feedback on the production readiness of their systems anytime somebody makes a change to them. And you can perform push-button deployments of any version of the software to any environment on demand. So continuous delivery could be any release cadence. Okay, so let's say that you release monthly. For instance, GitLab, they do major and minor releases on the 22nd or 23rd or something like that of every month. So they're doing continuous delivery in their major releases. They, and for this point here, your team prioritizes keeping the software deployable over working on new features. So the important part is that you don't break the build with your new feature.
Boo!
It's not that you put down features and go and work on DevOps code or whatever it is all the time. It's just that you don't break the build. That's the key. You get the build working, and you make sure you don't break it. And this part is again about automated tests. So CI is a big part of continuous delivery. Your software is deployable throughout its lifecycle. So that means that, like, let's say a dev has just made a change. They've got a little branch in their source code management system that they want to test out. They should be able to deploy it to a testing or a development environment that's like live, and it should work in that state. They shouldn't break the build. It should stay deployable, but and more importantly, any environment here, you should have multiple environments dedicated to multiple stages of the thing, and they should be as similar to production as possible. So that way, whatever it takes to get your software to production, you can use those same methods in your staging environment, in your development environment, in your beta environment, or whatever other envs you have. So no matter what, I take software, I pitch it out at an environment. I don't have to care. Oh, this is on dev, and so I have to whiz the bangs and flew the flobs and whatever first. No, I don't care. It's just an env. It's just treat your systems as cattle, not pets, or whatever.
So your dev environment is no longer a Wild West crazy town. It's actually controlled by the same continuous loop.
Exactly, yes. And you can still, like, the dev environment is still a good place to let a developer log in and use a debugger if they need to, and change code live if it's more convenient for them or whatever, but they still should test it again with a real deploy once they get, their live changes done and they're ready to try it for real. You know what I mean?
Right.
So it's fair to say then that they may go in and modify things manually. But before they're allowed to push this change back, they should demonstrate that they can, through the CI/CD pipeline, push that change and have it automatically go through all of the checks and all of the changes and not require anybody to actually touch a thing, so that when they step over into production land, it runs through that whole cycle without a human being involved.
Exactly.
Yeah, and point of clarity for me, I guess. So, and when you say devs get to touch things in the dev environment, you're talking about you're talking about code and running that debugger and that sort of thing. You're not talking about actual like back-end infrastructure, like the server that the app or whatever runs on. They don't get to go in as admin and futz with services that are running.
Yes, that's correct. And honestly, like devs don't care about that stuff. Generally, they don't want to until they feel like they can't do something without that access. And so if you do the work to make the automated deployment stuff happen, then they're like, oh great, I don't have to deal with that anymore. And then when you lock the servers up next month and don't let devs at the database anymore, then they're just like, whatever, you know. Or, well, it's not that you shouldn't let them access the database and look at it. It's more that you shouldn't let them, like, create a new database and go and change all the settings and whatever, so
Yeah, and circumvent
So, yeah.
the pipeline.
And
Yeah.
part of this is the forcing changes as code, right? Like forcing, if I want to go in and spin up a new database, that should be something that's possible. Like I should be able to do that, but I've got to demonstrate that it's doable as code. I've got to demonstrate that it's an automatable process, and I can deploy it into the dev environment. And I don't need any extra access over what I had. Maybe I do to deploy that database or whatever, if that's what needs to happen. But it's a thing that I've gone through and demonstrates needs to be done through code rather than just, I want it.
Yeah. Exactly. So, I mean, at some point, if you make your feedback loops good enough, you can lock up your SSH access to servers altogether, or remote desktop, or whatever's in your relevant. It doesn't matter at that point. Devs, if they can get the stuff they need out of that dev environment, they won't care anymore. And they don't need sudo or admin access, whatever. Unless the system doesn't let them to get what they need otherwise. So, and to your point about automating, services and things like that, containerization helps with this immensely. Not only virtualization, right? That helps a good bit, right? But you still have a good bit of kind of setup and if you use it right, you could say make an image for everything. But containers are actually built from code. That's the whole idea of like Docker, is that you have a script that creates your container, and if somebody wants to get some new library that's on that container, all they have to do is change the script to say rpm install or whatever. And so when it comes up, it's got their new lib, and that works in every environment because you're using your containers on the development local machine, you're using it on your dev, your staging, your production. I wish I was there, honestly. Docker is pretty cool, but anyway.
Yeah, I mean that was gonna be my question. Is so it seems Docker, the developers are pushing that, not necessarily your normal old graybeard system administrator server person. So because it sounds like to me what you're saying is that this environment should be set up for the devs, but the devs aren't maintaining the container environment and things like that. But I have just found that there's more devs that understand what containers are versus system administrators.
Yeah, and that's true. So again, I think the key here is to remember that, think of it less of a walled garden where you have like dev on one side and sysadmins on the other side. And dev's like, here's the code, sysadmins, and throws it over the wall. And it's your problem now. Deal with that, And the Oh, Boba Fett suddenly appeared.
That's Phasma. That was Phasma.
Oh, excuse me. That's that
God,
was...
get your nerding right.
I haven't watched all the new ones, okay. Um
Fair enough.
but yeah, so they I lost my train of thought now. It's the point is that there should be collaboration. So IT ops should be saying, well, this is the right way to implement this, while developers are saying, well, we need these libs, and they're saying, okay, well, we can get you a container environment, Kubernetes or something, and dev's like, okay, I can script up the container, and they work together. Like pairing is possible and quite key to this. It's when those two functions get together, that's when you are really doing DevOps, is when you're actually like sharing knowledge across that across the wall, or just tear it down, Pink Floyd style.
Right, and the so we were talking in my example earlier. I talked about creating a database like on the fly, being able to just do that in code. Part of this is providing an API, a programmer interface, to allow someone to make changes to the system in code, and as a consequence of that, you're defining the changes that you want to allow a developer to make to the system. For like, I want to allow a developer to start this service, stop this service, deploy this, install a new service, install a new database, what have you. But you're automatically doing a thing that we've wanted to do for a long, long time, which is very meticulously control what system changes can be performed by what users. And so we tell a developer, look, if you want to make a change to the system, you want to install this new service that runs with these permissions, this is how you do that.
Right.
And you define that very clearly.
Right. You go and edit the Docker file, and in order to get that out into a real environment, it's got to pass all the security tests and dependency vulnerability scanning that all of your Docker images go through, right? And so if you automate that and you make it easy, which, easy is an easy word to say, but it often, like, the devil's in the details, yes, but a lot of these things just take a little bit of pointed effort. Like if you actually make it a point to do this, it usually, it's a couple of weeks or months of iterative, like getting it better and better, but you can get a long way in a short time. And I'll get to tools and stuff like that in a bit. But
so next month, are you going to tell us how to build a CI/CD pipeline?
I will probably get to that today. I'm going to show you some working code. So
if we stop interrupting him.
Yeah.
No, you guys have great questions, so I'm glad you're not all falling asleep as I talk about this dry theoretical claptrap. So continuous delivery is great, but if we just do continuous delivery, our parrot's a little bored. He's like, it's cool, I guess we can like ship stuff once in a while or whatever, but it's not like we're not doing it all the time. It's like we're still waiting, we're still collating all these changes. We probably have to build some kind of a release candidate and then ship it all at once out to production. We're not really going as fast as we could. Okay, so that's where continuous deploy comes in. So I'm going to back up here. Continuous delivery is the basis, right? And that says you should be deployable all the time. You should have CI and testing and all that other stuff. You can perform push button deployments to any environment, but it doesn't specify that you constantly release. Continuous deploy is the practice of releasing every change to production as soon as it is ready. New software changes are first run through the automated testing, and when all the tests pass, it's automatically shipped. Off it goes into the wild blue yonder, or down the tubes. If tests fail, code is sent back to a developer for more revisions. So we get a happy dancing party gopher at this point. Somebody mentioned, was it a gopher earlier? What was it? A hamster, a
Parrot
gerbil,
guinea? A gerbil
Close enough.
guinea?
The
Something
guinea
like that?
pig.
guinea pig. Okay, this
The
is close
old
enough.
guinea
right?
pig.
Yeah, this is like close enough. It's a protein hamster, something. Anyway, and my favorite line is "ship it," and this is one of my favorite and most overused emoji on our Slack is the "ship it" parrot. It's basically the parrot on a boat with a little sailor hat on. It is a low. It's not one of their higher res, so it looks like trash on this presentation. But
So
No ship it squirrel.
yeah, so
you know, it's I like
so
it too.
ship it is where you put something through the CI process and it doesn't quite work in prod, but you send it to the customer anyway. Is that correct?
Um,
Jesus Christ!
no, that's more
My
like
God!
that's more like fuck it, we'll do it live. Ship it anyway.
That's appropriate.
Ship this shit. That's that GIF. That's a different
Well,
GIF.
so
Okay.
so to Corey's point though, like so we're going through dev, QA, and all the other non-prod environments, and then we're testing for like security stuff.
So your security testing actually happens every step of the way. So as soon as a dev pushes up code, that's where we run all the unit tests, all the functional tests, all the security tests, and everything gets tested. Not before it's even deployed.
Well, so that's the question I had because you said earlier, and I was waiting to see where this was going, but you said we don't break builds earlier in the process. But if we're not breaking builds, how are the developers getting feedback that something's messed up?
Right. So you definitely like want to keep the build working, but like you can run your tests in a lot of cases, you know, unit tests and security tests, all that can be done without even shipping anywhere. So you can go ahead and start running your tests as soon as we go. Is my microphone jacked up?
Oh yeah,
Yeah.
Mr. Roboto. Sorry,
Weird. Does it clear itself up
it's
or
better now.
magic?
It's how you
I
hold
don't
your
know
nose.
if there's like somebody's turning on a microwave periodically. It's just fucking your microphone up or what, but
It's David.
Gosh, that'd be
It's
kind of cool.
Free Amazon feedback every time.
that is David. David's just got like a fucking microwave gun beaming at your house.
Probably.
Every
If
time you
it's
start
really-
talking.
If it's the neighbors and their damn degausser again. I've told them about that. I don't use magnetic storage anymore. You know, ever since that raid, we won't talk about that. I'm sorry. No, okay. I could actually I have a desk mic I could switch to here.
No, you're fine. Keep going.
No, you're good.
Yeah.
It's kind of
Okay.
it's kind of a fun game.
It is. So yeah, continuous deploy though is the idea that if you feel like you're confident enough in all the tests that you have, that if all the tests pass, then you can ship it. That's pretty cool. And a lot of people, a lot of shops probably that say we're doing continuous deploy aren't actually like merging code when just automated tests pass and then automatically shipping it. They're probably still having somebody like hit that merge button at the end to bring the code into the main line and ship the whole thing to prod.
So how would you compare that to a hotfix?
So everything's a hotfix at that point.
Okay.
It's all hot fixing.
To Tim's question, maybe and this is me drawing off of my past experiences. So we had an environment that we had, we had dev 1 through whatever, QA 1 through whatever, I forget whatever the other like 2 or 3 environments we had, model. And so when you're saying deploy it, so you would run that CI process through each one of those environments. So you might run the CI process for dev 1, it passes, you go to dev 2, then you push it to QA1, then you might skip QA2 and go to model or what have you. So you're doing that for each maybe environment, depends on your process, but environment that you have.
Yeah. So what we do, I'll get more into that in the demo.
Okay.
Which of course the way that we do it is the best way. But we're always improving it, so we're just pushing the envelope. That's how we work. No, there's you're basically right. Like your devs work on, how do I need to test this to get my feedback? Like I put it on the various dev environments and it works here. I found a problem in this other environment that's like maybe a little different or something. However, I would caution that if you have multiple dev environments like dev 1, dev 2, dev 3, and if they have any differences at all whatsoever, you should just make them all able to do everything. So melt away the differences between the environments because they should all be homogeneous. Again, you want to treat your servers like cattle more than pets.
Right.
The end game would be to have environment A have these set of features turned on, environment B has these set of features, environment C has these set of features. They all have the same code.
Yeah, but
Right.
the way you could do that is move all those feature flags into something like your database, and simply, when environment 47235 comes up, when you look at customer feature A demo customer and feature B demo customer, those should work because those customers have those like features
Right.
turned on or off. So you can melt away through the code. You can get rid of that like specialized environments, and again try to remove as much as possible the like customization of environments, because you want your servers and your environments to be commoditized. You want to be able to delete every environment created again anytime. It shouldn't be special.
Yep.
So again, continuous deploy is CD as well as continuous delivery, but continuous delivery is less time constrained. It's like we'll still ship it whenever we decide it's release time. Continuous deploy is every time is release time. We're going to ship shit constantly. Okay, so to pull all this together, I thought of it as like layers that build on each other. And if Agile was an onion, it would be a sweet, sweet Vidalia, of course. So if we cut away the layers, and oh, that's weird. That's not, knife is really crazy. Okay, so if we cut away the layers, and we think of the whole onion as like Agile development practices, then within that, a subset of Agile would be DevOps. DevOps practices like build on Agile methodologies. DevOps is just a way to do that. And then within DevOps, you have continuous delivery. So that's like you take the DevOps ideologies and processes and practices, and you build on those, and you have continuous delivery, right? So you're constantly releasing stuff. And then within that, you have CI/CD. So that again is like where you're saying, well, part of my continuous delivery methodology is I'm going to build these pipelines, and they're going to be used to deliver value and iterate. Continuous integration. Sorry, I ran out of room in my onion, so I used an emoji. But continuous integration is like a subset of CI/CD. It's very important. It's basically the backbone. And then within that, you have continuous deployment as that builds on CI, continuous integration. So I thought this would be an easier way to visualize it rather than all these jargon and theoretical mishmash. So hopefully that's helpful. Okay, any other questions or kind of general stuff? This sort of...
No, I got to give you a break on this one.
You guys have asked a lot of great questions already. So, oh, I don't remember. Oh God. Yuri, who's Yuri? I'm sort of confused.
What is happening here?
Agile methodologies are sort of like poetry.
I've seen this game.
That slide, it had a really pretty knife.
Have you now?
I like knives.
Thanks for the presentation.
Knives. Sorry?
Thanks for the presentation.
So, I don't know what's going on. I don't remember making this slide. Oh. I don't know. I'm gonna do that. Yeah, that sounds like a good. Oh no, choose water. I don't want to. Okay, I'm gonna choose. Oh, okay. Okay, this is really creepy. We have our parrots.
There's parrots. I feel safe now that the parrots have arrived.
Something's wrong with the parrots, though.
I can has parrot.
This isn't right, guys. I don't know. David, did you do this?
I've not done this.
Show you my slides. You did something. Oh God. Okay. Okay. Oh God. What's it? Make more slides with knives. Make more. Oh jeez. Okay. This is weird, y'all.
Oh God.
All right. Apparently, we're just doing waterfall now. That's all. No more.
Yay!
More DevOps.
It makes me so comfortable.
Forever. Okay. Anyway, so how does security fit into the DevOps lifecycle? You've probably been wondering this the whole time. Like, what is he going on? This is a security talk. So security can be built into many phases of the DevOps lifecycle. So sometimes referred to as DevSecOps. And it's kind of like, oh, we forgot to put security in, so let's paste in the word sec into DevOps.
That'll make it better.
That's common for us.
Yeah. So
cough, ColaSec.
Sorry, guys. Yeah. So you can one really basic method is static application security testing, or SAST. Static analysis programs exist to detect security vulnerabilities in new code changes. So that's like one of the easiest things you can automate in terms of security testing that goes into your continuous integration flow. DAST is dynamic application security testing. That's a little bit more advanced, and I didn't write it out. I don't know why. Anyway, in the monitoring phase, you can do automated security probes and pen tests on every environment after new deploys. So, when you let's say you've just deployed to staging, and QA is going to go give it their like expert eye. You can, in the background, be running pen tests on the security and the staging environment to see like what's up. Is there anything new? Is there any sort of like regression in terms of security? That looks like a good upside down sherbet. Nice. So you can actually put that into your automation, like trigger a service that goes out and rescans an environment. License management can be added in, so you can tell like what's where, what are we paying for, do we have all that up to date, and secret scanning. You can do some again, it's sort of another form of SAST, but you can check and see if devs accidentally committed some passwords or keys into the the repository, which is a big no-no. I'm sure you've all heard of people publishing their AWS keys to GitHub and getting automatically compromised, and then a couple $1,000s in server charges later. The AWS sends you an email and says, "Whoops, guys, you should probably turn those servers off. We didn't really mean to do that."
Oops.
Have you seen the keys in the API? Like, I've had one of my pen testers. He's able to decrypt the password or keys in the API.
Interesting. No, that's a little scary, and that's why you rotate your keys. And that can really that's another thing you can automate and build into your life cycle. Like for instance, there are secrets managers out there where you can request a password to a thing. Say it's your database password. Obviously, there has to be some kind of a master password at some point, or key that unlocks it all. You can try to get all that as out of your app code as much as possible, because we've all been there. You make compromises, you ship things fast, and you're like, well, I'll just put the hard code that password here for now, and then it sits there in the app for the next 6 years until finally it is compromised.
Are you going to talk about some of the DAST and security scanning for committed password key? Okay, then I'll save my questions.
Yeah.
Okay.
And I'll say I don't have like a ton of knowledge about them, but I know a couple pieces, the ones I've used essentially. Okay, this one's dressed up for Halloween. Oh God, he brought his friends. Okay, anyway, moving on. Everything's fine. It's fine. Just put the fire over here with the rest of the fire. This presentation is clearly breaking down. I don't know what happened. I did this late at night. I don't really remember a lot of this stuff. So tools. You've all been waiting to hear what are the tools available for this. Shiny, happy tools. So how would we technology without shiny, fun, new tools? There are a lot of tools on the market to support creating a CI/CD pipeline. Okay, so you have Jenkins, you have Circle CI, you have Travis CI.
Jenkins, God damn it.
These look really weird. Well, I mean, it is Java, so Jenkins is probably more appropriate.
Jenkins is appropriate. That's appropriate.
GitLab. Okay, that's just cheap. This is terrible. Who wrote this crap? David, did you do this?
I have no
This
things.
is supposed to say Azure DevOps. Okay, this is just like cheap jokes. Oh, AWS CodeShip is the correct product name. Okay, all right.
There she is. See, it
More
wasn't
anime
me.
girls. Yay.
Oh, great. All right. Well, I think we should just like skip ahead. Oh, God, here we go. This is now it's just like random GIFs, and what's even why is this even here? This doesn't make any sense in the presentation. So okay, all right. This is just this is what 2020 feels like. This is
It's a
what
CI/CD process.
That's
Yep,
it right
there you
there.
go. This is
That should have been
I think it's
slide
CI/CD
number 1.
process and waterfall because it's steps.
yeah. You know there is an Escher with waterfall.
I'm not sure what I'm watching is the waterfall or the CI/CD. It's
You know what? Let's just skip to the demo, okay? Because this clearly there's something wrong with this presentation. I don't know what happened. There's all that crap. It's all there. I don't know. Anyway, okay. Enough of that. So get that report. Dang it.
Next time.
Next time. Okay. So here's a bunch of DevOps books to buy and support. Jeff Bezos and Ignore Your Family at Christmas. So the Phoenix Project got a mention. Only Amazon. The Unicorn Project is the and actually I have the Phoenix Project right here. I planned ahead. Look at me. So there's the Phoenix Project. Cool thing about this book is that it is a novel. It is not a technical book. It is about this guy who apparently is 16-bit, and he's an IT manager, and he has to figure out how to turn his business around. It is actually pretty interesting read, and the version I got had the first couple chapters of the DevOps handbook at the end. So you get a little bit of bonus material, so that's nice. I recommend this if you don't have any, if you just enjoy, thriller, techie novels, or if you just want a good intro to DevOps that's like interesting, and not just a dry like here's some theory kind of stuff. The Unicorn Project, actually, David is borrowing it right now. So if you want to see the cover, he has it. But it is the continuation of that saga with different characters and some switch up. And I actually haven't read it all the way through yet. And David just borrowed it because I wasn't reading that at the moment. So the DevOps Handbook I have found very useful. I am not all the way through it. But there's a lot. I've been kind of skipping. Oh, yep, David's got the Unicorn Project. It is kind of pink, so fitting for unicorns. So in it, it seemed good from the couple first chapters I read. DevOps Handbook is like all of the principles that they talk about in those two books, kind of in the theory stuff. So you have like, how should you structure your team, and how should you measure stuff? You know, your feedback loop, all that. It's all in here. So then we have continuous delivery. I put deployment on the slide. That's incorrect. Again, Evil Bezos must have changed it. I think he was the mastermind behind all of this.
Damn it!
My slide. But continuous
slides are inadequate. Try
delivery.
again.
Share some authors with those other books. Jez Humble and David Farley do a really good job here. Again, this is like foundational stuff. It's not the like, let's ship everything to production immediately kind of theory. It's more like, let's keep the stuff buildable. The goal. The link I put on here is to the graphic novel, believe it or not. These books, the Phoenix Project and the Unicorn Project, are based on The Goal, which is about lean manufacturing. So like these are about saving your IT ops using lean and DevOps. This is about saving your manufacturing plant. It was written in the 70s about like Toyota manufacturing processes, and it's basically the same story, but from the point of view of a plant manager who has to save his plant in order to make his company profitable, so hundreds of people don't lose their jobs. Kanban, and by the way, this one, since it's so out of the IT world, I recommend you just read the graphic novel. It's a comic book one. Kanban, this one is not that long. It has a good bit of stuff on like, how do you use boards? What are swim lanes? You know, all that stuff. Why use Kanban? Where it came from? Again, lean manufacturing. Blah blah blah. The lean startup is more about business, but lean principles again applied to business. If you're doing technology or managing technology, you should read this book. If you know technology managers, you should read this book. Everyone should read this book. Apparently, it's like if you go to MBA school, this is like the entrepreneurship Bible now that they all push. That one's really good. You want to go way back in software development. The Mythical Man Month is a book about waterfall development and why it sucks. Why adding more developers to a late project will make it later, and there is no silver bullet. Those are the it's like a not very long. It's like a collection of essays. I recommend that. And then I have to pour one out for my overlord Jeff Bezos. The Amazon Web Services in action is just like a bunch of stuff you can do with AWS. We use AWS. Blah blah blah. You might not use it. Books.
Woohoo!
Woohoo.
Take my money, Bezos. Just take it.
So,
and if you have nightmares because of this presentation, here's probably why. Go play if you have 4 hours to kill and like horror literature, interactive horror literature. Go play Doki Doki Literature Club. It's free, and then you can make horrible text and send it to your friends. And then of course the Cult of the Party Parrot. And that's all the slides I wrote.